third years. I just wanted to run through a couple of the corrections from the problems that I posted for you to do on Monday. So we had questions 2, 3, 6, 9 and 10. So I'm just going to run through corrections that I've done for each of these. First one was nice and straightforward. We just had to name the number of axes of symmetry that each of the shapes had. So for part A, you can see there we've got a rectangle and it's got 2 axes of symmetry. I'll just tick the number there beside it. Part B was a scalene triangle from what I could see. So it's got 3 sides of different lengths, which means it have no axes of symmetry. Number C was a 6-sided or 6-pointed star, I should say. 1, 2, 3, 4, 5, 6. So we can have an axis going through each of the points. So you can see them there. There's 3 that cut it in half point to point, and then in between each point in the center parts there, we can also have an axis of symmetry. So it gives us 6 overall. Part D had none as well. We had a, what shape was it? I can't remember. Anyway, but it had no axis of symmetry anyway. I think it was a different type. It looked like a star, but it was an unusual shaped star, wasn't it? So I had maybe one side that looked similar, and then I had this, and I had something like that. So it was it wasn't symmetrical in any way. Anyway, and then the last one, part A, looks kind of like a face. It's got 2 eyes and a triangle, or 2 circles and a triangle down the center. So we have one axis of symmetry there. If we go right down the middle, we'll be able to cut it completely in half. For question 3, we had a few different shapes. I think we had a letter P, we had a car shape in one of them, as far as I recall, and we had something else as well for the next ones, but as you can see there, I've just run through the corrections so far. The first one was the letter P, and you had a translation first of all, then it was passed through central symmetry, then it was passed through axial symmetry, and then the same for part B, same for part C. It just went through each one, what happens to them. Question 6 was quite a good one as far as I can remember. Based on it, I don't have the question in front of me, but you had 2 boxes beside one another with an X on them, like that. And I think they were rectangles. These look more like squares, but you get, yeah, and you had each point was named, and we had to talk about the length AB. So say, for example, that was AB, and it was being passed through a certain translation, and it tells you where you need to go. So the translations were given to you along the middle, along the center there where I'm putting the dots, and they were given to you, and you had to figure out, okay, if the point E, or if the line E is being passed through this translation, where would it end up? And we just had to run through them each there. So you can see for the first one, we've got the point C, then we've got the segment DC, the point F, the triangle ABE under central symmetry gets moved to become a triangle EDC. The line segment goes through axial symmetry, becomes HF, and the triangle ABE under axial symmetry through DC gives us another triangle HFG, or any combination of those letters. It doesn't matter what order they're in. I think in the answers in the back of the book, they're in a different order, but it doesn't make a difference as long as you name the 3. So for a triangle, it doesn't matter. And when we're talking about an angle, it does matter what order they go in, as you know. The only thing I'll point out to you, or to highlight to you, what you can see is here, when we have a point as the posed question, your answer is always going to be a point. In a segment, your answer is always going to be a segment, and in a triangle, your answer is always going to be a triangle. You're always going to end up with the same shape, or the same vertex, or the same point, whatever it might be. It's going to be the same. It's just changed its position and condition, so whereabouts it is, or its orientation. So it's still going to remain a triangle, or a line segment, or a point, or a square, or whatever it might be. It's just changing where it's sitting on your graph depending on what translation you use. Question 9 then was tricky enough, and we had a bit of drawing to do, and I saw from your corrections that you guys have posted up, lots of people got good diagrams drawn, so very impressed with that. Nice and simple. We have our 3 lines drawn in colour, and I matched the colours from the textbook just to make it easier for you. But all we had to do was pass this triangle here. I'm going to mark it in green. This is the original triangle given to us, and we had to pass it through axial symmetry in those 3 lines. So the first one was through the line Q, which is there, and you can see all we had to do was map it to Q. So map A to Q, and then map it from, I'll go back, hang on. I'll map A to Q, and then move it the same distance again from Q across to where it would be. And you do the same for B. You go to the line and then you stretch it at the same distance again. C to the line and the same distance again. So you just keep an eye on where you're going, and as I said, it's a straight line all the time, so you got to be nice and careful with that. Straightforward enough with the Q line, and the P line in this case in R was a little bit trickier because you're going kind of diagonally across the graph. So you can see what's happening for A part 1 through the line Q. We've got a mirror image. Through the line P then is the same idea. We've got it there, and it's being flipped upwards, as you can see. But again, those distances are the same amount above the line P as it is below the line P, and you just got to keep that in mind when you move the 3 points. And then, as I said, for the final one, get rid of these so you can see with the line R, and we're in blue. So for that line there, we can see what's happening. It is a mirror image from here, from the original triangle to where we're at there. And again, the distance between. So the way I did it myself, instead of trying to draw a straight line like you did for A part 1 or for A part 2, what I did was, you think about it, how you get to the line. So how do I get to the line or from A? And what you did was, I went across 1, 2, 3, 4 parts. So you went 4 spaces across to get to the line R, which means I had to go down 4 spaces, 1, 2, 3, 4. And the image of the point A is there through the point R when I go through axial symmetry through the point R. And the same idea, you could do it there. Look, you can see I only had to do 1 space across for B to get to the line, so I go 1 space down. And in that one for part C, you go 1, 2, 3, 4, 5 across, which means you have to go 5 down. Sorry, not 5, 4. 4 across, which means I have to go 4 down, and you end up where we need to be. So I think that that's an important thing to keep in mind, especially with that line. R was a little bit trickier than the 2, than the green one and the red one, because they're just a straight line like you would do through the x-axis or the y-axis, just in a different position. So I think they were a little bit more straightforward. The second part of that question then was asking you about just writing the coordinates of the points. So once you've got the translation done correctly, writing down the coordinates of the triangles was pretty straightforward, I think. So they're the coordinates for, let's go back, do it in the colour it's supposed to be. So through Q is the green one. So we've got the coordinates for the new triangle here are written there. Through P is that one, and its coordinates are there, the 3 coordinates again. I didn't put them in any specific order, I just wrote them down as whatever way I could find them easiest. And then finally our third triangle and our coordinates of the 3 points there. So that's all that was expected to do for the second half of that question. And then finally, you were given a graph. Again, I'm just going to do a quick sketch. You were given a graph, something like that, and you had 4 triangles on it, and it was done something along those lines, and you had to talk about what's happened to this triangle when it's been rotated to here, or rotated to here, or rotated to here. So all you had to do was talk about what was happening. Now, we talked about positive and negative, and if we were unclear on that, our negative rotation is clockwise, which is a bit counterintuitive, I know, but you just got to be careful with it. If we talk about a negative rotation, we're moving clockwise, so we're going in that direction as the arms on a clock would go. And then your positive is the opposite, anti-clockwise. Okay, so as I said, anti, and I'll write CW for clockwise, and that would be going in the opposite direction. So if we're going backwards, as if the arms on the clock are going the other way. So I've written most of these, you can see positive 90 degrees through the origin, negative 90 degrees, negative 90 degrees. There is the opposite, which is the same as that. You can imagine I could say that would be a negative rotation 270 degrees through the origin if you really wanted to do it, but I'd try and keep the angle value as low as possible here. And again, you could say the same for the second one and the third one. Instead of doing negative 90 degrees, you could say positive 270, and then in the third one here you could say positive 270 as well. That would also be correct. So if you wrote that down, that's fine too. And then for the last one, as you can see, it could be positive or negative. Because it's a 180 degree turn, it doesn't matter what way you go, you're still going to end up in the position you were supposed to. So you can imagine yourself, if you are facing one way and I ask you to turn 180 degrees clockwise or anti-clockwise, you'd still end up in the same position. You'd still be facing opposite to the way you were originally. So it doesn't matter what way you go. If you turn right or you turn left, with a 180 degree rotation, you're still going to end up in the same position regardless of which way you turn. Okay, so I hope that makes a bit clearer for you guys, and we'll be able to attempt the next few questions today. Thank you very much.